Hi everyone, in this video we look at how to graph the function y is equal to 1 over x. So let's first produce a table of values to look at to figure out what the corresponding y values are for values of x. Well, okay, let's let it read x, y is equal to 1 over x. Now let's try to write out okay, let's write this as minus 3, minus 2, minus 1, minus 1/2, minus 1/3. Let's do 1/3. Oh, whoops, let's do 1/2 first. No, 1/3, then 1/2, then 1, 2, and 3. And we could put, we could do 4, I guess we could fit on this grid. And we could fit -4 on the grid as well. So you might have noticed that the x values that I chose are a little bit odd because I didn't choose all integer values for x. I also chose some fractional values for x. The reason that I did that was because if you think about it, if you divide 1 by -3 and you divide 1 by -2, you'll get fractional values and fractional values for y. So although these are integer values for x, we get fractional values for y. If I want to get an integer value for y, I can do that by dividing by like -1/2. If I divide 1 by -1/2, that's the same as 1 times -2. Because remember that division by a fraction is the same thing as multiplication by the reciprocal, and the reciprocal of -1/2 is just -2. So let's go ahead and we'll fill out this table of values. So if we do 1 divided by -3, well that's equal to minus 1/3. 1 divided by -2, that's equal to minus 1/2. 1 divided by -1 is minus 1. 1 divided by -1/2. Let's think about that. 1 divided by -1/2 is okay, 1 divided by -1/2. Well, that's equal to 1 times -2, because division by a fraction is the same thing as multiplication by the reciprocal. So 1 divided by -1/2 is -2. This is -2. So then division by 1 divided by -1/3 would be -3. 1 divided by 1/3 would be +3. 1 divided by 1/2 would be +2. 1 divided by 1 is just 1. 1 divided by 2 is 1/2. 1 divided by 3 is 1/3. And 1 divided by 4 is 1/4. So now let's go ahead and we'll plot all of these ordered pairs. So it seems like there's a lot, but it's really not that bad. So let's first plot -3, 1/3, and let's scale it such that this is 1 unit on the y-axis and that this is 1 unit on the x-axis. So we'll scale it such that each grid space is 1 unit. So -3, our x value of -3, -1/3 is about there. We've got another coordinate at -2, -1/2, which is about here. So we have let me make that point a little bit smaller. Then we have -1, -1, which is here, and -1/2, -2, which is right here, and -1/3, -3. And we can put in -1/4, which would give us -4, and here we could put in -4, which would be -1/4 for our y value. So you can kind of see that as what the shape of this graph looks like as we connect all these points. This is a curve, and the curve looks something like this. Now, if you remember from from some of the last few videos, let's think about what the domain. Let's think about what the domain of 1 over y is equal to 1 over x is. So the domain, well, remember that division by 0 is undefined. So we have that the domain is the set of x values in the real numbers such that x cannot be equal to 0. The range, well, the range is equal to the set of y values in the real numbers such that y cannot be equal to 0 as well. So let's go ahead and we'll finish off this plot, and then we'll talk about the domain and range, and we'll talk about we'll notice some things about this and some characteristics about this graph. So let's plot 1/3, comma 3, 1/3, comma 3 would be right here. Then we have we could plot 1/4, comma 4. Let's throw that point on there as well. 1/4, comma 4 would be about there. We also have 1/2, comma 2, 1, comma 1. We have 2, comma 1/2. We also have 3, comma 1/3, and 4, comma 1/4. So let's go ahead and we'll connect these points with a smooth curve. And then we'll see if we notice anything about the graph of this function. So this is y is equal to 1 over x. That's the function y is equal to 1 over x. So a couple things to note. Because the domain is such that we have x is an element of the real numbers, such that x cannot be equal to 0, this graph can never touch the x-axis because the range is y is an element of the real numbers such that y cannot be equal to 0. So this graph cannot touch the x-axis because our y value for the x-axis is 0. And according to the range, we've got that y cannot be equal to 0. So if we think about it, if we think about plugging in larger and larger values for x, we would get smaller and smaller values for y. Like if I plugged in 5, I would get 1/5, which is even smaller than 1/4. And 6, I would get 1/6. And then let's say I plugged in, an x value of 1,000. Well, I would get even closer to the x-axis because I'm just getting smaller and smaller values for y as x increases. Alternatively, as I get closer and closer to 0, I'm getting larger and larger values for y because when I divide by, if you take 1 divided by 0.000001, that's going to give me a really, really big number. So as we get smaller and smaller positive values for y, these smaller and smaller positive values for x, the y values get larger and larger. But we can never touch the y-axis because then we would have x is equal to 0, and we know that division by 0 is either undefined or indeterminate. In this case, because we're dividing 1 by 0, that would be undefined. Now, let's look at the negative portion of this graph. So here we've got the negative values for x, and we can see that as we get closer and closer to 0 for negative values of x, our values for y increase in the negative direction. And then as we plug in smaller and smaller negative values for x, larger and larger negative values for x, we get smaller and smaller negative values for y. So we get really, really close to the x-axis, but this graph never touches the x-axis. So as this graph continues, it'll get closer and closer to the x-axis, and this part will get closer and closer to the y-axis, but it never touches the y-axis, and this portion never touches the y-axis, and this portion never touches the x-axis. So this is called, when this happens, this is called an asymptote. So it's a value that the graph gets infinitely close to but never touches. So this is called, the x-axis is called a, whoops, this, I just realized that's going to be off the screen when I write that. So the x-axis is a, whoops, the x-axis is a horizontal asymptote. So a horizontal asymptote. And the y-axis is a vertical asymptote. So this is a vertical asymptote. And that's the graph of y is equal to 1 over x.